All right, guys, so we have watched in class the Einstein's Big Idea video. If you guys remember that, it was about Einstein and all the scientists that came before him that helped him, give him ideas as to figuring out this E equals mc squared kind of thing. And so if you remember in the movie or in the equation, energy equals mass times the speed of light squared, right? And so basically, what that boils down to is that the universe and everything in it is made of two things, matter and energy. So in your notes, what I want you to do is this kind of be a big page where you have a universe on top, and then you're going to copy what you're going to see on this screen, matter on the left side and energy on the right. And we're going to take a look at the difference between the two and just highlight a few things about them. Just kind of get our understanding of how the universe works, and what it's made out of, because in chemistry we're going to be focusing on what it's made out of. So on the left side we have matter, right? So matter is the stuff of the universe, the physical stuff of the universe, made of atoms, right? And you guys know about atoms: protons, neutrons, and electrons, or the three main parts of the atom. And then, scientists in the last 50 years have found even smaller parts of protons and neutrons and whatnot. And so there's all kinds of quarks and all kinds of other parts within the atom as well. Now, atoms can make up, what are called elements. Elements are pure substances made up of only one type of atom. So we're talking about like this here is a picture of silicon, Si on your periodic table. That is made out of just pure silicon atoms. This here is a picture of chlorine gas, again Cl2, right? And so that is made of pure chlorine atoms. So we call anything that's made of pure one type of atom, we call an element. Now, atoms can also combine with each other in order to make compounds. And that's what this side is. Okay, so compounds. So for example, water. When we have two hydrogen atoms hooking up with an oxygen, we make water. And that's a compound because it's made out of two or more different types of atoms. Okay, and so in our journey of chemistry this year, we're going to take a really good look at atoms and how they make elements and compounds and how they can rearrange themselves in chemical reactions and whatnot. So we're going to focus a lot on this left side, this matter side of the universe. But we can't forget the right side, okay, the energy side, because energy is what drives everything. It's what drives the movement of the matter in the universe. Okay, so there's two, basically energy can be divided into two different types. Okay, we've got potential energy, all right, which is on right here on the left side of the energy. And that is what we call stored energy. Potential energy is stored energy. Is something that has, if you have potential, that means you have, an ability to maybe in the future do something well. Well, potential energy is the ability to move, okay, but we're not moving yet. So it's stored energy that's not, moving yet. And then we also have energy of movement, moving energy, which we call kinetic energy. All right, so kinetic energy, any moving object is what we call, it has what we call kinetic energy because it's moving. So what we're going to do is we're going to take a look at the energy side of the universe and the different, kind of types of potential versus kinetic energy that's possible. So we're going to start with potential energy, stored energy, energy that is like waiting to be unleashed. And so there is 4 basic types of potential energy. We've got elastic energy, and elastic energy is energy found in like something that's wound up, like a wound spring or a stretched rubber band, something that, the material is elastic in nature, and so when you stretch it and you hold it there, it's got the potential to move and fling and spring back or something like that. So that's elastic potential energy. And then we have gravitational energy, which is energy provided, because of a force between two objects. So like, gravity here on Earth is what keeps everything kind of, on the surface of the earth and not floating up above it. And so if you hold a ball up in your hands, it has gravitational potential energy because it has the potential for gravity to take over as soon as you let go of it, for gravity to take over, and boom, it falls down, right? So that's what we call gravitational potential energy. And then we have chemical potential energy. Chemical potential energy is energy stored in the bonds between the atoms. So if you take a look at this picture, this is kind of a representation of a compound, and atoms are held together in compounds by bonds. And so we can break bonds and release energy. That's what we call chemical potential energy. So lots of things have chemical potential energy. Even the food we eat is chemical potential energy because it involves, it's made of chemicals and compounds that our body, when it digests, it breaks those bonds up, and that's how we get the energy for our body to use. So we can eat and sleep and exercise and learn and do all the things that we do throughout the day. So that's chemical potential energy. And then the last big type of potential energy is what we call nuclear energy. And nuclear energy is found within the nucleus of the atom. And we're going to learn a lot about the atom in chemistry this year. And we're going to see, that the atom, the nucleus, is made up of protons and neutrons. And when the nucleus of certain atoms gets big enough and the ratio of protons and neutrons is too high, the nucleus in the atom becomes unstable, and it can let out energy. Okay, it wants to become more stable, and so in order to do that, it will let out energy. So this is kind of a nuclear fission sequence, one type of nuclear energy that can be harnessed. Nuclear energy is turned into kinetic energy when through nuclear power plants and whatnot, and so that all has to do with nuclei of certain atoms. Okay, so potential energy, again, stored energy, and there's 4 different types: elastic, gravitational, chemical, and nuclear. Now on the other side of the energy spectrum, we have kinetic energy, or moving energy. So anything in motion has kinetic energy, and there's 5 major types of kinetic energy. So the first type of kinetic energy is pretty basic. It's motion energy. Anything in motion, like this bicyclist here, he's in motion, so he has kinetic energy. Big things in motion have kinetic energy, or what we call motion energy. But if we take a look at the on the molecular level, we can also look at how molecules are moving. The faster they move, the more energy they have. The slower they move, the less energy they have. And when we look at look down at the atomic and molecular level of their movement, we call that thermal energy. Okay, so that's our second type of kinetic energy, is thermal energy, looking at atoms and molecules and how they're moving. If they are moving very slowly, okay, then they have low thermal energy. Okay, those guys are going to feel cold. If they are moving very fast, they have high thermal kinetic energy, and they're going to feel hot. And we're going to figure out why in the next unit. Let's see, the third type of kinetic energy is sound energy. So energy, or sound, is a type of energy. It's the vibration of objects that, eventually the vibration gets into vibrating air molecules, and those air molecules are vibrating and hitting our ears, causing more vibrations. Those vibrations are detected by our brain, and bam, we detect it and unencrypt it as sound. Okay, And so sound is a type of energy because it's movement of molecules, vibrations of, from one object, okay, giving off vibrations to the air, and the air vibrating as it, hits our ears. So that's what we call sound energy. Another really important type of kinetic energy, remember that in our Einstein's Big Idea video, Faraday did a lot of experiments with this, electromagnetic energy. Okay, electromagnetic energy is found in the electromagnetic spectrum of all around us. Okay, so remember he was, interested in, excuse me, interested in light, right? And that he said that perhaps it's just one type of this electromagnetic energy that he kind of discovered with the magnets and the compasses and that kind of thing. But there's a whole spectrum of electromagnetic radiation. Light was only one of them. We have everything from radio waves down here, the very, very low frequency radio waves. And as we go, further and further, more energy waves to the right here, we've got microwaves, we've got infrared, we have visible light, UV rays, okay, and then we have X-rays, like when we go to the dentist or doctor and they take X-rays of our bones and teeth. That's the kind of energy that they're using. And then we've got gamma rays, very, very high energy, that's let off in nuclear. That's part of our nuclear potential energy. When that's released, it turns into gamma rays. Okay, so this is an electromagnetic spectrum all the way from extremely low frequency waves that we use in communication, okay, on this end, and in radio, all the way over to the high energy gamma rays let off in nuclear reactions and explosions. All right, so again, movement. Okay, the energy in the electromagnetic spectrum is going to move particles and move information through the air, and so we call that kinetic energy. The last type of kinetic energy that we're going to take a look at is electricity. All right, it's something that we're very familiar with in the 21st century, and basically electricity is the movement of electrons. All right, so that third part of the atom. We can manipulate electrons to give us energy. And so the movement of electrons down a wire or even through a battery. Okay, batteries have stored up chemical potential energy, and then when you turn something on with a battery, those electrons inside the battery are moved into the object that is being turned on, and so we call that electrical energy. So when you plug your cell phone in, all right, you are getting electrical energy through the wires in your house, through the cord connecting to your cell phone, and it's charging. It's feeding your battery electrons, okay. And then when it's full of electrons, bam, you can unplug it, your cell phone, you can turn it on, and then that electrical energy is converted into heat and light energy to make it work, and so you can see what's going on, on your phone or device. So, as I kind of alluded to, energy is always there, whether it gets stored up somewhere, maybe inside of a battery, okay, or inside the food, okay, that we eat, and then potential energy turns into kinetic energy, energy of movement. Okay, bonds get broken, in food, for example, and they give us energy so that we can, convert that to motion energy, and we can move and run and talk and speak. And then, the same thing with electric energy that comes from the chemical energy stored in the battery, turns into electrical energy, turns into light and heat. Like all of these are just kind of all combined. And all related to each other. So potential turns into kinetic, kinetic can be stored into potential. It all goes back and forth, and no energy is ever lost or gained. It all just kind of goes into a different type. All right, so now that we kind of have a big picture of how our universe is set up and created between matter and energy, we are going to jump in and focus on the energy part in this next unit. And so we'll leave it at that, and we'll see you next class.